Before writing our first NLP program, let us understand two important concepts related to NLP. First of them is called the recurrent neural network, or the RNN, and this is a special kind of neural network. Let us understand the RNN from the given diagram. So if you see the cell number 1, it is getting input from the previous layer or previous cell and the X0, and then the cell is giving two outputs. The first output is the y0 hat, as you can see there. It may be used for different purposes, but it is not carried forward. But there is another output which is h0, which is forwarded to the next cell. So it's a kind of modified feed forward network where you are forwarding the output of first cell to the next cell as the input. So your cell number 2 will get the h0 as the input plus x1 as the input. So now your cell number 2 has two inputs and it is also giving you two outputs. So each cell has two inputs and two outputs. The inputs are coming from two different ways. The first from the x and the second from the previous cell's derivation. And it also gives you two output. The first is the y hat and the second one is h. If you see the last cell, again it is getting the input from the previous cell, which is hn minus 1 and xn, and it is giving you two outputs, yn hat and the hn. As the mathematical formula and its derivation is beyond the scope of this course, we will not be discussing RN and its mathematical implementation. Another type of algorithm which is most frequently used and which is more powerful in terms of natural language processing is the Lst M, and it is also similar like RNN, but there is a difference in the RNN and Lst M. In RNN, the state of the cells are not preserved, they are only forwarding the output to the next cell. But in Lst M, you can maintain the state of the cell, you can preserve and forward the state of the cell to the next cell also. So as you can see that apart from the h0, state of the cell 1 is also forwarded to cell 2, and similarly for the remaining cells. If you want to improvise it further, the Lst M long short term memory also provides you a feature called a bidirectional Lst M, where your cell states are maintained in both the directions. It means that cell 2 has the state of cell 1. Similarly, the cell 1 also maintains the state of cell 2, and so on. Again, this is beyond the scope of this course, so we will not be discussing mathematical implementation of Lst M. However, in the next program, we will see how the Lst M can be used in the NLP. But while you are working on Lst M, you may find a figure which looks like this, where you have x0 and the output of the cell itself is sent back to the cell as an input. So this is Lst M, and let us see a program where the Lst M can be used in the natural language processing. Now let us see practically how NLP can be achieved. In this example, we will see the IMDB review analysis. There is a database for the IMDB reviews. So we will use that database which is available in the Keras. So let us start with the import cell. As usual, we are importing the required libraries, and these all are the same libraries. You can see Lst M is being imported with the embedding. Embedding is something new which we will see in this example. After having the libraries, now we want to load the data. We can call the imdb.load data. We have already imported IMDB in first line, so we can call imdb.load data, and we are passing the words which is equal to vocabulary size, and we have set vocabulary size to 5000. The IMDB load data will return 4 sets of data: xtrain, ytrain and xtest, ytest, and then we are printing the length of xtrain and xtest. It will take some time as it will load the data, and then it will show you the values. It has loaded the data set with 25,000 training samples and 25,000 test samples. After having the data in the xtrain, ytrain and xtest, ytest, let us see how this data looks like. So we are calling the first record xtrain 0 and ytrain 0. So once I run this, it will show me a sequence. If you remember that in previous session we discussed the tokenizer, where each word of your sentence is considered as a token and is converted into a unique number. This part is already being done implicitly in the dataset. So whatever the dataset you are loading is already tokenized dataset, and that's why you are seeing the number of sequences instead of the words. So your review is shown in the numbers and there is a label given for that, which is 1. Now let us try to understand this by converting this numbers into the words by using a reverse method or by using a decode method. So if you want to get the word index from the dataset, you can call the imdb.getWordIndex. It will give you the words and its indexes, and then we are using some logic to convert the reviews numbers into the words. Since your data is encoded, now we want to decode it and we want to see how it looks like in the language. So we have taken xtrain 0 example and we are passing it in the loop to get the corresponding words for each number, and then we are seeing another example with the record number 3, that is xtrain 2, and let us print this so we can see the output. So first it downloads the imdb word index.json. You can download it and you can see it in your computer. If you see, the first line shows you the xtrain 0 and the second line shows you the decoded data. So 1 represents question mark, this is represented by 14, film is represented by 22. Similarly, all the words have a corresponding number in the dataset and it's a word index. Now you can compare and you can verify it because this film gives you 14 and 22. Similarly, if you compare here, you can see this film is also there in the second review and it is also mapped with the 14 and 22 number. We have taken I minus 3 here because first 3 words are the reserved words, so we are skipping them. In the next cell we need to pad the sentences because they may be of different length. Already tokenizing part is done, but we have to pad the sequence based on our requirements. So we say that we have mix words equal to 500 and then we want to pad the sentences. So again we are taking the first review. If you see, it starts with 1, but once I pad this review, I will be able to see it in different format because now it is padded for 500 words. So you can say the initial zeros and then the sentence starting with 1, 14, 22. In the next cell we are initializing the model. First we are setting the embedding size, which is 32, and then we are creating an instance of the sequential model. After that we are adding the embedding layer. This embedding layer requires 3 parameter: vocabulary size, embedding size and input length. All these are set in the previous cells and we can use them here. And the next line, in the next line we are adding an LSTM layer with 100. LSTM stands for long short term memory, as discussed in the first part of this session. In this last line we are adding a dense layer because it's a binary classification. There are 2 possibilities, 0 and 1. So we are calling the sigmoid as the activation function, and finally we are printing the summary of the model. So you can see that there are 3 layers and the results are shown there. Now it is time to compile the model. As we are working on binary classification, I am using binary cross entropy with the Adam as the optimizer, and I am using the accuracy for my metrics. Now we are adding one additional thing here. Every time we used xtrain, ytrain and xtest, ytest. In this example we are dividing the xtrain dataset into 2 parts, the train partial and validate. So we have now 2 segments of xtrain. The first one is xtrain and ytrain, and the second one is the xvalid and yvalid. So xtrain partial and ytrain partial is a segment which is a part of xtrain and ytrain, having all the elements starting from batch size till the end. And xvalid and yvalid, its batch size is 64, so their length will be last 64 records, and this will help us in evaluating the model very well. After dividing this data, next is another feature which we are adding in this example. In the previous examples we have seen that when we fit a model, we have to wait till the model completes the fitting for the number of epochs. So if I have set the number of epochs to 15, I will need to wait till all the epochs get over. Now it may happen that you may achieve the desired accuracy in the 10th epoch, but still you need to let the machine complete the training part. To prevent that on the fly and to stop on the fly, you can use the function for the callbacks. We have created one class called myCallback, in which I am passing tf.keras.callbacks.callback. In that I have defined function. It's an overridden function where I'm calling on epoch end, and in that I'm setting the desired accuracy, that is 0.90. So I want to stop when the accuracy is reached to 90%. We are interested in validation accuracy, so I am writing this statement: if validation accuracy is greater than or equal to 0.9, that is 90%, then the learning process should stop. So it says that stopping training as validation accuracy is reached to desired accuracy, and then it will automatically stop the training. And this we will use in the fit function. So this will save your GPU time and your processing and your waiting time. Once the accuracy will be achieved, it won't further train the model and it will stop there. Now it is time to fit the model. I'm setting the num epochs to 5, and then I'm saving the model.fit results into history. I'm fitting the model in xtrain partial and ytrain partial, as you have seen in the cell number 11. And then validation data, I'm setting x valid and y valid instead of x test and y set. My batch size is the batch size of 64 and epochs are 5. And then at the end I am calling the callbacks is equal to callbacks, which will call this my callback class, and then it will make sure that the training stops when the desired accuracy is achieved. So let us run this model. So as you can see that in the first step itself, it has reached to the 90% validation accuracy. The validation accuracy here is 0.92, and that is more than the desired accuracy. So the model has stopped training and it has given the message that the accuracy which was desired is achieved. Now it's time to test the model because we have evaluated the model during the fitting. Now it's time to test the model with x test and y test, and then we want to print the test accuracy. So let us run this and it will give us the test set accuracy. So we are getting around 85% accuracy for the testing data set, and it's not very bad. It's quite acceptable for the NLP. Now it's time to test your model with the different reviews. So this cell is another feature which we have added in this program, where you will ask the user to input some reviews, then you will fit that data into the model. Model will classify it as the positive or negative review. So we are calling this input method to get the input from the user. Then we should convert this sentence into the proper tokens as per the IMDB dataset's word index. You must remember that the word index may be different for each dataset. Say for example, in your dataset 1, your this refers to the number 14, but in your dataset number 2 it may refer to the number 10. So you don't know the exact number mapped with the word. So we are again calling the get word index from IMDB, and then we are converting the sentence which has been entered by the user to the exact numbers as per the IMDB dataset. So this is a crucial step. If you miss this step, you will have the unexpected results. After having the tokenized sentence, you can pet the sequence with the max length, which is set to max words, and finally you pass the x new to predict the model, and it will predict the class. The return result will decide whether the review is positive or negative, and it can be either 1 or 0. 1 means positive and 0 means negative. So let us run this. I have already set 2 sentences for you. So first sentence, the first review which I want to test is: this film is the worst film I have ever seen. Let us see what the model tells me. It gives a warning which you can ignore, and it says that it's a negative review. And as you can see, that it was really a negative review. You can rerun this again for another sentence. So the another review which I am passing is: excellent, superb film, worth watching, and as expected it has returned the positive. So this is how the natural language processing can be implemented. You can test with different reviews which have the words which can help the machine in understanding the type of review. It may be negative or positive, and it will return the results accordingly.